Okay, so this video is for topic 3 and 4, 3D figures, cross sections, and then surface area. So we have really 5 vocab terms that we're going to use for the 3D figures. The first one is a prism, which is a solid 3-dimensional shape with 2 bases, so 2 base shapes that are congruent and parallel. Okay, so the 2 that are parallel in this picture would be this and this base. So those would be our bases. They're congruent to each other, they're exactly the same size, and they're parallel. They would never intersect if you were to extend them in both directions forever. So this figure is named by the base shape, triangular prism. So it's a type of prism, but it's triangle because that's the base, and we call it a triangular prism. A pyramid is similar. It's a solid with 1 base, and it meets at just 1 point at the top. So it doesn't maintain its thickness, it doesn't have 2 bases, it just has the 1. But you also name it by the base shape, and then you put pyramid. It's a triangular pyramid because the base is a triangle. We have a couple other shapes that your bases could be, which is a 4-sided figure, so we know like quadrilateral. The quadrilaterals include rectangles, squares, trapezoids, things like that. If it has 5 sides, then it would be considered a pentagonal prism or pyramid. 6 sides is a hexagon. 7 is a heptagon. 8 is an octagon. 9 is a nonagon. And 10 is a decagon. Okay, so those are going to be helpful when we're saying if the base shape is a different amount of sides than 3 or 4. So heptagon, this would have 7 sides on the bottom, 7 sides on the top, so it would be a heptagonal prism. And then anything that has a circular base is going to be one of these 3. So the circular base here, we don't call it a circular prism, we just call it a cylinder. Okay, so the bases are still circles. This one, same thing, we don't call it a circular pyramid, we call it a cone. And then a sphere doesn't really have a base, it just is a 3-dimensional circular figure. Okay, so for this part we want to classify each solid and then highlight or shade in the bases. And then we're also going to identify the vertical and horizontal cross sections. So there's a video on the website for vertical and horizontal cross sections that you'll need to watch. It's like a 1.5-minute video, and then you'll be able to do the second part of this. Okay, but I'm going to do the first part first. So I'm going to shade these bases. In this case there's just 1. And it meets at a point. So this one would be a type of pyramid, and the base shape is a rectangle, so this would be a rectangular pyramid. Okay, this one has a circular base, so it's going to be one of the 3 on the bottom column, so it's just a cone. And then so on. You're just going to shade the bases, and then you can identify what type of shape it is. Okay, so take a minute to do 1 through 12, and then just check. I'm going to flash the answer key, and just check to make sure you got those correct. Okay, here are our answers for those shapes. On number 7, because it's a quadrilateral, we don't call it a quadrilateral prism. We name it by the specific quadrilateral shape, so trapezoidal. Same thing with the square here. We would name it by the square instead of quadrilateral pyramid. Okay, again, if you will watch that 1.5-minute video for the cross-section instruction, the graphics online are a little bit better explaining it than I am able to just draw it out. So the vertical and horizontal cross-sections, for each one I want you to identify the vertical and the horizontal cross-sections. So for the vertical, that means if you cut it down here, what shape would you see? And after watching the video, you should be able to tell that you would see a triangle if you cut it vertically. If you cut it horizontally, you would see a rectangle. So you can just identify the 2 shapes you would see for all of those. So you can go ahead and try the rest of those on that paper. and then here is the key for that. Okay. Then we get into surface area and surface area today. So the surface area is really the area of all of the surfaces added together. So what we want to do is recognize, okay, this shape, it has really 6 sides. If I were to unfold it, you can see that it looks like this. Okay, so originally it's a box like this. Okay, so we have this box. If I were to unfold it, zoom out, as far as it zooms out, but you would see this, the left and right side and the bottom are 3 sides. Then the front and back would be 4 or 5 sides, and then the top would be the 6th side. So really the shape is made up of 6 rectangles. They're not all the same size in this picture, so we just need to figure out how many of them are different and do the area of that different amount times however many there are. So for this picture, for instance, if I shade this left side, dimensions of that rectangle, so the left, and I'll put the left/right rectangle, the dimensions of that one are 7 by, this would be, the height would be the same as this height, so 7 by 9. Okay, and I have 2 of those. So 2 7 by 9 rectangles. Then I'm going to be adding to that the top, which is the top and bottom. Both of those will be the same. I have 2 of those because I have one on the top, one on the bottom. And that would be a 7 by 13. Doesn't really matter where you put the 13 and the 7, but it's a rectangle, so they can be on either side. And then we have 2 of the front face kind, which is the front and back. And they're 13 by 9s. Okay, so those are the shapes that we have in the figure if we were to separate them out. So again, that's 2 rectangles plus another 2 rectangles, and I'll put rectangle 1, 2 of rectangle 2, and 2 of rectangle 3. Alright, the area of rectangle 1 is base times height, so it's going to be 7 times 9 plus base times height, 7 times 13, plus base times height, 13 times 9. Okay, then you're just going to evaluate what that equals. So 2 times 7 times 9, 252. Oh, that's too big. 2 times 7 times 9, 126. I know 63 is this, so I know that was too big. So 126 plus 2 times 7 times 13, 308, plus 2 times 13 times 9. So my answer will be 542 in feet squared. Okay, so the rectangular prisms, you're going to have 6 rectangles. So on this one, you'd have rectangle, the left and right rectangle. You need to figure out the dimensions of that. Then you'd have the top and the bottom rectangle, dimensions of that, and then the front and the back rectangles. So you get the dimensions of 3 different rectangles. And I'm going to draw it separately this time. So rectangle 1 plus 2 of rectangle 2 plus 2 of rectangle 3. Okay, and I'll just do the first one. The rectangle 1's dimensions are these 2 sides. So this is a 5, that's the width, by 16. And then you would continue on. Okay, so I'll let you try those for 3 and 4, 2 and 3. Any other kind of prism, you have to identify the amount of shapes there are. So if I were to unfold this, I would see, I'll grab the foldable thing here. Okay. So if I had a, and I can identify the base shape, so if I had a triangle here, and a triangle here, these are my base shapes. So it's going to be something like this. The triangles aren't going to be the same, like it's not equilateral, but you can get the idea from this. So you have a triangular prism, so the 2 bases are triangles. And then what we want to do is unfold it so that we see what it looks like. So we would have the two triangular bases, these two sides, and then three rectangles that are the lengths of the triangle sides. So this side of the rectangle matches up with this side. This side matches up with this side, obviously, and then this side matches up with this side. So on our prism, we have two triangles that are exactly the same size. So there's always going to be two of whatever the base shape is. And then because it's a triangle, it has three other sides, so that means there's going to be three rectangles. And in this case, they're all different because all the sides of the triangle are different. So the sides of the triangle are 9 and 12. This is a right angle because this is a right angle. And then the 15 would be here as well. Okay. So the triangles area, we have 2 times 1/2 BH. And then, of course, the rectangles all have BH for their area. So we need to figure out what dimensions are of the triangle. So the triangle's base and height have to be perpendicular, so we're looking for that right angle. And it's the two sides that border the right angle. So it's going to be 9 times 12 here, plus, and then we have three different rectangles. So the rectangle 1, I'll put this side is rectangle 1, so it's this by this, which is 9 by 16. Rectangle 2, I'll make the right side rectangle, which is a 12 by 16. And then rectangle 3 is the front face, so this 15 by 16. So then we're going to be adding those things together. So 2 times 1/2 is going to give you 1. Okay. So really we're just doing 9 times 12, which is 108. I'm going to do them separately this time so you can actually see what the numbers were. 9 times 16, so 144. 12 times 16, and 15 times 16. Okay, so those were what the dimensions of the rectangles, and then the two triangles together were. So when I add all those together, I get that 684 meters squared is my area. Okay, 5 is going to be similar to 6 because it's a triangular base, so it's still going to have 5 areas were added together, 2 triangles, plus the 3 different rectangles. So I'll let you solve that one. 6 is a little different because the base shape is the parallel congruent sides, so a lot of people will think, okay, the rectangles are on the bottom and top, but this rectangle on the bottom is not the same size as this rectangle on the top, so those are not the base shapes. So the base shape in this would be the trapezoids. Because they're the same size and they're parallel to each other. So we have 2 trapezoids. And because the trapezoids have 4 sides, there are going to be 4 rectangles. So rectangle 1, rectangle 2, rectangle 3, and rectangle 4. Alright, so the 2 trapezoids area is 1/2 height, base 1 plus base 2, and then obviously we've done the rectangles enough to know that it's just BH. Alright, 2 times 1/2 is just going to go away, so the height of the rectangle, or the trapezoid, we need to figure out. So how tall is it right here? Well, it's the same dimension as this, so it's a 12. And then the bases are the parallel sides of the trapezoid, so it's 18 and 23. And then we have the 4 rectangles. So this one I'll call 1, the top I'll call 2, 3 for this one, and then the bottom will be 4. They all have the same width of 15, so this is 15 on all of them. So really you're looking at the other dimensions. So it's 12 by 15, 15 by 18, 20 by 15, and then the bottom one is 23 by 15. Okay, so you're going to do all that calculation. And solve for that. So 20. So you should get 1587 when you do all of it together. So those are our prism volume, or our surface areas. 2 more on the back side. On number 8, they don't give you this side, so you do need to use something that we've been using, which is the Pythagorean theorem. And this is the hypotenuse of the triangular base. So that's your hint to do that first, and then you can do what you did before. Okay, cylinders have a little bit of a unique situation here. So, with a cylinder, if I unroll it, if I cut it along one of the little sides of the cylinder and unroll it, you can see that it's going to be 2 circles and then a rectangle. So the rectangle's height is the distance between the 2 circles. So that's how tall this is, the distance between the 2 circles on this picture, which would be 26. The rectangle's base is the length around the circle. So if I were to close this side up and this side up, it's actually the length of this, it matches up with the length of this around the circle, which is the circumference. So when we draw our rectangle out, the dimensions of it are circumference, which is 2 pi radius, times the height of the cylinder, which is 26. And then again, we'll have 2 circles. Okay, so we have the area of a rectangle. So this is a rectangle, and we only have 1 rectangle, and we have 2 circles. All right, the rectangle's base is 2 pi r, so we're going to put all that in for the b, times that by the height. Okay, so it's base times height, but all of this is the base, and this is the height. And then 2 of the circle's areas, which is pi r squared. Okay, so you're just plugging all that in and solving. So in terms of pi, I'm not going to multiply the pi part. I'm just going to do 2 times 11 times 26. So it's 572 pi. And then 11 squared times 2 is 242 pi. So then I add the 242 and the 576, it's 814 pi. Okay, so that's my answer in terms of pi. Timesing that by pi gives me my answer as a decimal to the nearest hundredth as 2,557.26 yards squared. And then you have some application problems on the bottom. Again, I still identify, okay, there's 2 rectangles that are one size, which is this. Then you have 2 rectangles that are a different size, which is this. And then 2 rectangles that are the third side, which is this. And they have to total 272. So you need to get the rectangle's dimensions for this side, which is a 2 by 12. The rectangle's dimensions for the top, which is a 2 by L, so we'll call it 2x. And then the front would be 12 by L, or 12x. Okay. So then you're solving the algebra. So this turns into 4x and 24x, and then just 2 times 12, 24, so 48. Okay, combine like terms and solve, so I'll let you do that part. Find x. And then on 12, you're just going to work backwards to find the height. Trying to go quickly, we're almost out of time before. Okay, so find the surface area of the pyramid. So the pyramids are going to have, I'm going to grab the last shape. So we have a pyramid here. We're going to have 1, 2, 3, 4 triangles, and then the base, whatever the base shape is. So our base shape is a square in this case, but I'll just use a rectangle because we don't have the square area. And then we're going to have all the, since it's all 8s here, all the triangles are the same exact size. So we have 4 of the area of a triangle. Okay, so it's 8 by 8, and then 4 of the triangle's dimensions would be, base is 8, and the height is 11.7. Okay, so then you're solving the algebra for that. So a lot of these are pretty similar, except for you might have a different base besides a rectangle. The one that is a little bit different is 3. They only give you the height. They don't give you the height of the triangle, which is what you need for the area of the triangle. So you're going to have to use Pythagorean theorem with this triangle here. So you're going to have 3 is the height. If this side is 16 and it's a square base, then the height is going directly to the middle, so this is going to be only half of that, or 8. So you do the Pythagorean theorem and solve for C, which is your height of your triangular sides. So you still have the rectangle, and you have the 4 triangles. Okay, so 16 already based on height of the rectangle. Your triangle's base is 16, and then your triangle's height is whatever you get for C. Okay, so then you can solve it. And then the last one, they already give you the area of the base, so the hexagon area, you don't have to use a formula, they give you the answer. So you just start off with that, and then you add the 6 triangles. Okay. Alright, so the answers for that paper are here for all 3 of those papers. Okay. And that's it.